I want to welcome you to revision week. And of course, exam is on Friday. The exam is going to be written in this venue on Friday. So I'm going to use today and Wednesday to walk you through practice questions and what you are expected to bring into the exam hall. With the nature of the questions that are being structured, you are allowed to come into the exam with calculator. You are also allowed to come into the exam with your laptop. But what you're going to do on the laptop is just maybe you want to make use of the R software. It is not compulsory that you should use the R software, but if you want to use that, that's no problem. Okay. The exam, I'm actually going to allow a cheat sheet. Okay, a cheat sheet of where you can write a formula and of course both side. Okay, so um I actually uploaded this practice questions. So if you get yourself familiar with these questions, of course you are on the right path. So while four of us said I should review the assignment or what you've done in the assignment before. And of course, this practice, questions. I'm going to start with question number one. So before going into question number one, like I said, you are allowed to come with calculator. You're also allowed to come with your laptop. And the only thing you want to do on your laptop is you want to make use of this software, nothing more. Because I'm actually going to be going around that day to make sure you don't do something else on the laptop except using the software on the laptop. Ah, okay, so go ahead. Can you what? Yeah, yeah. So I'm going to start from problem number one. Let X1, or before going into this problem, is there any question? Is there any other question regarding the exam? And on the day of the exam, I will advise that you arrive like 5 minutes before, like at least 5 minutes, okay? To get ready because we only have 15 minutes for the exam. Okay, so um, let's go into the question. The practice questions are provided, starting with problem one. Let X1 and X2 be independent with normal distribution, so which means the normal distribution will be tested on the midterm since it's coming up on the practice. So the X1, X2 be independent with normal distributions. Of course, you're giving 6, 1, 7, 1. That is giving you the mean of the mean and the variance of X1 and the mean and the variance of X2 are given here. Find the probability of X1 greater than X2. This question can come in different kind of form. Of course, you know that. Maybe I know that the height of female follow normal distribution and the height of male follow normal distribution. What is the probability that male is greater than female? So stuff like that. Okay. Now, if you want to solve problem like this, please pay attention now. Pay attention. I want to solve a problem that has to do with this. I will automatically convert this into this x1, okay, minus x2 greater than 0. Because if x1 is greater than x2, then the difference between x1 and x2 should be greater than 0. Does that make sense? And why am I doing that? I'm actually doing that for me to be able to use the idea of a linear combination, whether they say greater than or they say less than or whatever, we actually going to want to use the idea of a linear combination. So what I'm going to be seeking to do now, I'm going to be focusing on the difference between that. And that difference, I can refer to that as a W. So which means probably what I want to find here is more or less like I want to find the probability of W greater than 0. So W is the difference. If I want to find the probability of W greater than 0, then I need to know two things. What is the mean of W? What is the variance of W? Okay, so what is the mean of W? Like I want to find what is the expected value, okay, of W. Okay, expected value of W is the same as the expected value of X1 minus X2. You see the way I'm approaching this question right now? And when I take the expectation of that, it's going to be the same thing as the difference between their means. Okay? And you know what? The mean here for the first one is 6, as specified. The mean for the second one is 7, as specified. If I do 6 minus 7, that will give me -1. And that was how I got the -1 here. Is there any question? That's how I got the -1 there. Then the next thing I want to find the variance of W. Okay, I want to find the variance of W. If you want to find the variance of W, you can actually use the approach that we use in class where I actually have A, okay, and I'm actually having the covariance, but here there's no covariance. You are only giving the variances. So what I'm going to do, since it's looking as if the covariance is 0, maybe the X1 and X2 are independent. So what I'm actually going to do is I want to find the variance of X1. Please pay attention. You do not understand, ask me question, because it is when exam is reading that one will be able to know whether you understand the message I've been passing across. Now, the variance of that now is going to be the variance of X1, okay? The variance of X1, okay? Plus. So whether you are subtracting or not, it's going to be a plus. Okay, so plus the variance of X2, but the minus is going to call me now when I do -2, okay, into the covariance. But right now, if I say -2 into the covariance, okay, it doesn't look as if there's a covariance. But I'm just going to write that out. So the covariance here is 0 because we didn't give that information. It's going to be 0. I'm just going to add the variances. Now, what are the variances? Look at that. 1 and 1. 1 plus 1. What do you have? 2. And that was how I know. Let me tell you this. Whenever they ask you what is the distribution of something, what they need you to specify is what is the mean? What is the variance? So the distribution of x1 minus x2 now, is normal with mean of -1 and the variance of 2. Because if I don't know the distribution, which means if I don't know the mean, if I don't know the variance, I would not be able to have a reasonable probabilistic computation. Does that make sense? Any question on that? please ask question. Please ask question if you don't understand, if you get stuck. Okay, now the next thing that I'm actually going to do now is I will go by way of a standardization. I want to find the probability of x1 greater than x2, which is the same thing as the probability of x1 minus x2 greater or equal to 0. Now, what this is the going to be the now let me tell you the real interpretation. Okay, some of you may be wondering, how do I come across this? Okay, that's a z-score. The z-score in this case, let me tell you, the z-score in this case is going to be w as a random variable minus expected value of a w minus expected value of a w divided by the square root of the variance of w. That is what we use. What was the w? The w is x1 minus x2. What was the expected value of W? That would be the mean, the -1 that you see here now. What is this variance of W? The variance of W is 2, but we're putting a square root. Don't forget, the z-score is W minus the mean divided by standard deviation. And that was how we arrive at this. Now that we're here now, okay, what is the next things that we actually are going to do? Now, don't forget, in the x1 minus x2, that would be 0. You're going to plug in 0. So is 0 minus 1, that is going to be 1. And that was how I got greater than 1 over square root of 2. Now, the reason why I said I allow calculator and allow other software in the exam, because there's no way you're going to move forward getting the 0.24 without putting that into our software or maybe calculator or whatever. Is there any question about that? The probability of x1 greater than x2 is 0.240. Let me tell you this interpretation of that. Okay, I'm going to give you an interpretation now. Let's say I'm referring to the height of male and female athletes. I'm just assuming. If I'm referring to the height, okay, of male and female athletes, okay. Now let's say the mean, maybe let's say the x1 is for female and x2 is for male, and we want to figure out what is the probability that of the female, the height of the female will be greater than that of the male. Okay, if I happen to be a coach, okay, I have athlete. Okay, now what I got here is 0.240. Doesn't make sense probabilistically, but how is it going to make sense? Multiply by 100. If I multiply this by 100, you know what I'm telling the world? 24%. 24%. Okay, that occur, which means 24%, of my athletes, female, they are greater, they have their height greater than that of the male. That's what it means. Okay. Is there any question before I move on from this question? We actually have today and Wednesday to go over this. Of course, Friday is the day of exam. And I need you to ask a question the moment you don't understand. Any question on this? Okay, I'm actually going to move. This is being recorded, and this is also going to be shared. Okay, this is being recorded. Okay, and I'll make sure this is posted on time because Friday is not far from here. Okay, so that is done. We're done with that. We're done with that. Now I need you to pay attention. I can confirm to you 100%. Something that look like this will be on the exam on Friday. I can confirm to you 100%. Now, take a look at the second part. If you look at part 2, this is testing bivariate knowledge. Okay, let X and Y have a bivariate normal distribution with respective parameters, all the parameters that we have, the means, the variances, the correlation. Using R, now let me tell you this. You can decide to use R or not. I'm not compulsory you to use R. Does that make sense? You can decide to use R. And that's why I said I allow calculator and R. I allow anything that will make you to succeed in the exam, except that, when you bring the laptop into the exam, it's only going to be, the only thing you're going to check on the laptop is just R software. Okay. Now, you are given this information about X and Y. Oh, give me 1 second. I think I'm going to do something now. Okay, let me make it so. Okay, so now you have all the information given, the correlation given. Now the first question, please pay attention on how I'm going to solve. I'm going to go about the first question. Find the probability of Y between 106 and 124. Okay, you want to find this probability. Now, when you take a look at, I need you to pay attention to question A and question B. Question A is focusing on a random variable Y. Okay. Question A to me is looking univariate, just univariate. But when you take a look at question B, if you take a look at this again, why is C between 106 and 124? But in A, it is no condition on S. But in B, even though we're still finding Y between 106 and 124, that is being conditioned on S. When it is conditioned and when it is not conditioned, how are we going to go about this? Please pay attention. I need you to pay attention. I first want to walk you through when it is not conditioned. Okay, when it is not conditioned, okay, so take a look at this. Y lie between 106 and 124. If I'm focusing on Y, I only need a univariate distribution centered on Y. Now, what I'm going to do, I already know they're giving me information. Pay attention. This is the mean of Y. This is the variance of Y. I need those information. That is exactly what I stated here. Any question? If I want to have anything to do with random variable, I need to first specify the distribution. Okay, specify that I follow normal distribution, and not only that, I also need to specify that, the mean and the variance. Now that I have the mean and the variance, now I want to find this probability of Y lie between 106 and 124. I'm actually going to have two forms of standardization. The first one, for 124, I'm going to standardize 124. So 124, okay, minus, what is the mean? The mean is 110, right? Minus the mean, 110, divided by, what is the standard deviation? The variance is 100. The standard deviation is going to be 10. Okay, so what is 124 minus 110? Okay, 124 minus 110 is 14. 14 divided by 10, that was why you get 1.4 here. You get 1.4 after standardization. After standardization. Now, I'm also going to standardize 106. Okay, it's going to be 106. Okay, minus 110. Okay, divided by 10. And that will give you negative 0.4 that you see here. Now, if they are going to find the probability of Y lying between that is going to be the same thing as probability of a Z lying between those two values. After standardization, the next thing I'm going to do is to go into my R. Going into my R, this is the code that you're going to write into your R software. And finally, you're actually going to get the probability to be that. Is there any question about how I figured that guy out? Is there any question? Please ask question if you get stuck. I want everyone in this class on Friday when I'm marking grading the exam to score A. That's my intention. If you don't understand now, this is the time to ask question. Stuff like this is coming in the exam. Okay, now that is done. I'm now going to go to the next question. The conditional one. Please pay attention. Pay attention. Okay. Now, I'm actually on this guy now. Okay. I want to focus on, I want to figure out the probability of y, given that I have information, the probability that y is going to lie between this. This is more or less like, oh, what is the probability of my patient having between maybe the BP of, or maybe the weight of 106 and 124, given that I have information about maybe some other variable that I've mentioned, okay, to be 3.2. Now, whenever this is a conditional, this is probability associated with a conditional. So because we're talking about conditional, then we're going to be focusing on a conditional distribution. Conditional distribution. Conditional distribution requires I need the conditional mean and the conditional variance moving forward. Now, don't forget, we got a formula. Give me 1 second. I'm gonna clean up this guy now. Okay, so we got a formula, right? Please pay attention. What I actually want to do is this guy here. I want to actually solve this problem. Then don't forget, I need a formula for conditional mean and for conditional variance. We have done this before. Conditional mean, expected value of y given x equal 3.2 will be equal to mu of y plus the rho plus the rho sigma y over sigma s minus mu x. And the variance is sigma y squared 1 minus rho squared. If I were you in your sheet, write the formula down. Okay, in your sheet, write the formula down. Now, what I'm going to do, I want to figure out the conditional mean and conditional variance for me to be able to have a meaningful probabilistic computation, which is exactly what I'm doing now. I'm just plugging in the values given. Then I got that. 116 is the conditional mean. 8 squared is the conditional variance. Is there any question about how I use that? Is there any question? Okay, now the moment I have my conditional mean and my conditional variance, I'm now set for statistical inference. I want to find the probability now because I'm actually going to be using the idea of a normal distribution, normality, facilitate standardization. Now, what I'm going to do now, I'm actually going to move. I'm moving. Okay, please pay attention. Now, just like the way I standardized the other time, okay, I'm actually standardizing again. I'm standardizing this guy and this guy again. Standardization now using a different mean condition. I'm going to use a conditional mean. So if I want to standardize 106, okay, it's actually going to be 106, right? Minus the mean that I got, the conditional mean, okay, 116 divided by, look at that, 8 squared, okay, the square root of that, I think, is going to be by 8, and that will lead us to getting negative 1.25. Okay, now I'm going to do the same for 124, 124, okay, 124 minus 116, okay, minus 116 divided by 8, okay, that is going to give me that. Okay. Now, if since that is what I'm actually going to have at the end of the day after standardizing, okay, well, when you have y between negative and positive, of course, you do the positive, you do the bigger one first minus the smaller one in R, automatically that will give you that. Now, there's one information, there's something I wanted to see. When I did not condition on a values of x, the probability was very small. But right now, after conditioning, 0.736. Look at that. So which is telling you there's a difference between the two. Is there any question on this? Is there any question on this? Okay. In the absence of question, I'm actually going to move. I think I'm impressed with the performance of this class so far, but I want to be more impressed after you have written exam. Okay. Now that is the end for problem one. We want to go to problem two. I think what I have today is maybe to walk you through problem one and two. Then on Friday, sorry, on Wednesday, the other problem, then Friday, your exam. Now, take a look at problem two. You've done this before. So as I've used this as an example in class. Okay. So uh the way we did it, just follow it. So I brought it, I didn't bring it up for a reason, or for just I actually brought this up for a reason. There's a reason why I'm bringing this up. So if I were you, why can't you go over it? It's we've already gone over this in during the lecture. Okay, we've gone over this during the lecture. So I think I'm gonna move away from that. Okay, we've done this during the lecture. Make sure you read that. Very important. So question one, problem one and problem two are kind of connected. They are connected. Okay, one and two, they are kind of connected. Okay, so let me move to problem three. I'm going to move to problem three. Now, and I need you to pay attention. Oh, give me 1 second. Okay, consider a bivariate number with all of these parameters given. Write out bivariate number density. Okay, now if the bivariate number density, I think I actually let me see if I can see. I think I have an entity here. EXP into minus R into X minus mu X over sigma that plus Y minus mu Y over sigma that plus 2 rho X minus mu X over sigma X Y minus mu Y over sigma Y. Okay, so I think I have 1 over 2 here into 1 minus rho squared or something. 2 pi sigma squared 1 minus rho or something close to this. Okay, something close to this. Let me see, this one have a squared. Okay, something, yep. This is bivariate density. It's just like you're giving all of this and they ask you to now, when you see mu1 is mu, same thing as mu of x, right? Mu2, same thing as mu of y. Okay, sigma 11 is sigma x. and sigma 2, 2 is sigma y. Okay. And of course, rho 1, 2, the same thing as rho. Okay. It's just like somebody asking you to plug in all those values, write it out, then put the values. Okay. So that's exactly what I mean. So if you, in a multivariate form, okay, if you don't want to go by this, you can actually write the multivariate form. You may want to write it in matrix. Okay, maybe I want to write my mu. I want to have a mu vector. I want to have a covariance vector. If we want to write it in a multivariate form, okay, this guy here is a multivariate form. But if you want to write it in a multivariate form, okay, then here your P equal to 2. Okay, you got x1, x2. That was why you have mu1 and mu2. Okay, now if you want to write it in multivariate form, your P, you have to say your P equal to 2, and your X is a matrix, X1 and X2. Your mu is mu1 and mu2, and the covariance matrix. Can you see that? The covariance matrix. Now, this is to tell you the covariance is the same thing as the product of correlation and the respective standard deviation. Okay. Now, if you take a look at the mu, here, look at the mu here, 0 and 2. Where do I get 0 and 2? Okay. See up here? Do you see this guy? 0, 2, 0, mu1, 0, mu2, 0. If I want to write it in a in a vector form, can you see that? That's why I have that. Now here, you want to set up the variance covariance, and I need you to pay attention. How do I set up variance covariance? Of course, 2 and 1, 2 is the variance of the x, and 1 is the variance of y. That has already been given. Okay, if it's here, sigma 1, 1, 2, sigma 2, 2, 1. But if you take a look at this, you were not given covariance. How are you going to get covariance? It's easy. Okay, you're actually going to get covariance using this. Okay, because in the covariance matrix, there is a covariance matrix. What you are giving, you have this guy, you have that guy, but you want to figure out sigma 1, 2. Sigma 1, 2 is the same thing as sigma 2, 1. If you want to figure that out, you're going to make use of this. You multiply your correlation given by the two standard deviation. And when you do that, that will give you this guy here. That's going to give you that guy here. Now, you're setting up your oh, sorry, not that one. That will give you this guy here. Oh, give me 1 second. Um, okay, so that will give you this guy here, which is the same thing as that guy. You have used this formula to figure it out. Now, after that, don't forget in this formula here, in the multivariate density formula, you need to figure how this inverse of this and the determinant of the covariance matrix. Now that you have you have the covariance matrix, I can find the determinant of it. Then I can find the inverse. After finding the determinant of it, don't forget here, the determinant is raised to power half. Here, I'm raising it to power half. It's like taking the square root. You see that? So the exam will test your computational knowledge. How do you compute? You have to be fast in doing it, okay, and accurate, okay, within the stipulated time, okay. I'm going to make sure you are not bombarded with questions, okay. You are not going to be bombarded with questions. And after that, after you're done with all of that, it's time to plug in that into this. So plug in that. You see my f of x? I've plugged in that. I'm done. You see the way I plug it? I plug that in. So my final answer now is just this. And the reason why I asked you to come with calculator, in fact, you can come with any form of calculator. Okay, why I say you come with calculator is because you don't need to find the inverse, the terminal manually. You can either use a calculator or you use the software R. Does that make sense? And that's why you can come to my exam with all of that. This motivated analysis. You need them. Okay. Now I'm done. That's for first. That's for first. Okay. This is in a scalar form. This is not in matrix. Okay. If you want to go by this, that's no problem. This is not in matrix. But the one I'm presenting now, that is in matrix form. Whichever one you want to actually use. Okay. Now go ahead. Okay, so how 2 pi I think that should be like 2 pi raised to power 3 over 2. Okay, let me do this. Maybe there may be some, maybe we're simplifying something, but let me do this. Now, it is right here. It is right here, right? Okay. That should just be 2 pi. That should just be 2 pi. Okay. Maybe it's a mistake because if I plug in 2 over 2, that would be 2 pi. Oh, then when you have a 2 pi, is that one? Exactly. When you simplify, I think I'm saying something now. You know what happened? Take a look at this. I think I got something now. If you if you take a look at this, trying to simplify them, you will see that square root of 3, there's a 3 inside that square root. And if you want to still put the other one in a root, okay, rationalization or whatever. So I think you will get it. Thank you for that. Okay, now um after that, so that's already done. Now uh then I'm gonna go to question B. Look at question B. Write out the square generalized distance expression as a function of x1 and x2. Okay, as a function of x1 and x2. Now, to write this out, we are still using this particular question. Okay, now your mu still remain your mu. You've already find the inverse. Now take a look at this now. What do you think? What do you think I'm doing here? Please pay attention. Okay, this guy. Okay. Oh, it's off. Let me see. Thank you. What about now? What do you mean? I don't think it's okay. What about, is it working now? Oh, it's working now. Okay, so as you can see, this guy, okay. So if you look at that, okay, minus mu, blah blah x1 minus that, blah. So that is what is written now. You see that? That is what is written now. So if you take a look at what I actually have, you're gonna see that this guy is the same thing as this guy that we've already figured out. This guy is the same thing as this. And of course, this guy is the same thing as that. Just multiply out. And you have been told that you're actually it's gonna be a function of x1 and x2. Okay? So it's gonna be a function of x1 and x2. Is there any question about that? Any question? You see the way I want it to be answered, okay? You see the way I want it to be answered? I'm not gonna rush you. Um, I still have some time, but I will advise that you go over this. You see that, right? Go over them. I think I've given this in an assignment before. When I said find the MLE and the sample covariance, I mean, and the MLE variance, okay? MLE, you can see the difference. MLE variance will be 1 over n, 1 over n instead of 1 over n minus 1. Okay, don't forget you have 4 observations here. Okay, okay. Now I want to spend time on problem 7. Okay, there are some theoretical questions. Let me tell you this. The exam will test your knowledge of computation, okay, and theory, your knowledge of computation and theory. You know, take a look at question 7. Let x1, x2 up to x20 be a random sample of n equal to 20 from, please always pay attention to what they say. Do you see subscript 6, right? What that is telling you the number of variables involved. 6 variables. Okay? Now the question says specify each of the following. They wanted to specify the distribution of this guy. Okay? Because this guy is looking like a quadratic squared. You know, quadratic squared, okay? The distribution is always going to be a chi-square. But do you know somebody can say chi-square and you don't get full credit? How are you going to get full credit? Please pay attention now. Please pay attention. How are you going to get full credit? You will only able to get full credit if you pay attention to this. 6. Look at that. Look at, do you see my answer here? What did I say? Distributed chi-squared with 6 degree of freedom. Look at that. This guy, this guy is always going to be distributed chi-squared, but the degree of freedom depends on the numbers of features that you have. Does that make sense? Okay. Like a question like this, take 1 second to answer. Just 1 second. Now, I'm going to go to the next one. Please pay attention. The distribution of sample vector mean and the distribution of this guy. Okay? So please pay attention. From univariate statistics, when sample size is large, whether sample size is large or you are choosing from a normal population, the distribution of a sample mean is normal. Does that make sense? Now, but here we're talking about vector of sample means. Okay? Now, look at the way I wrote the distribution. I said X bar is distributed. You can see I indicate 6 because that was what was indicated in the population distribution. This is a population. Look at that. That's a population distribution. The distribution, the population I want to choose from is already normal. Then whatever sample size that I choose from it, the statistic will also be normal because I'm already choosing from normal population. Now, look at what I said. The distribution of X bar will be as that mu, comma, Now, mu comma, please pay attention. My covariance will be divided by the sample size. Oh, from the univariate case, you know what we normally have in the univariate case? Sigma squared divided by n. You remember? That is the variance of x bar in a univariate case. In a multivariate case, sigma squared become variance covariance, and that's why you have that. Now, since you understand that, what is the distribution of this guy? That guy is like a z-score in a univariate statistics. Okay, the distribution is going to be 0, comma sigma squared. You remember the mean of a z-score is 0. Sigma squared can be 1. But right now, because I'm talking about vector, please look at the way it's going to be. We say I have 0, but you have to indicate n6, then variance covariance. Lastly, before I go today, what is the distribution of n minus 1 sample covariance? Okay, you know, if I have n minus 1, okay, and I have s squared in a univariate case, the distribution is chi-square. But this guy here is a sample covariance indicating that the distribution is going to be a generalized chi-squared, which is a Wishart. And how am I going to write? So I'm going to say Wishart, okay, and I'm going to write this. I'm going to write that. I start from 1 to n minus 1, zi the transpose, where zi, which means in the Wishart, individual zi follow normal in the Wishart. The Wishart is that summation, okay, zi, the transpose of that, I starting from 1, because you know why? The sum of squared, do you remember in statistics? Uh, if I have a z squared, okay, and I have I, and I want to sum it, I start from 1 to n, which is z1 squared, z2 squared, and so on, like, or maybe up to that. Okay, now the sum of squared of deviation follow a chi-square distribution in statistics, because, and don't forget, each of these is x minus mu over sigma. Okay, so this something squared is writing something squared in a matrix form is what we are writing here. You know, z transpose z is like something squared. Please pay attention to that. And that's going to be a Wishart. I want this exam to be a walkover. If you have not gotten A before, believe this time around, A is any statistical related subject before, believe it is the time to get your A. Just take your time. The review continue on Wednesday. The exam is on Friday. Okay, make sure you all stay safe and have a lovely day. Bye for now, everyone.